Hello and welcome to a discussion of Module 6 in Big Data Technologies. So jumping right in, what's the module about? And this module centers again on Spark, but from a perspective of Spark machine learning, so Spark ML. And by the end of this module, hopefully you have a pretty good idea of how you do pattern mining, evaluate the application to format data for application in the Spark ML library. So basically you have to get data into a data frame in a certain format so that you can do stuff on it, and then argue or discuss how classification and regression are important to machine learning. And that's kind of the whole point of ML. So what is machine learning and advanced analytics? I think of it as the application of techniques at scale. So it's basically AI at scale. And the intent being to look for solving a problem of a particular type rather than some of the areas of AI itself are kind of, a lot of them are theoretical, but many of them have applications, but yet whenever you talk about things like machine learning, it's all about the application of those concepts, be it statistical, connectionist, or whatever it is, to do loads at scale. You use it to find patterns, detect bad things, so anomaly detection, or good things, which could also be an anomaly depending upon the situation, or to do things like make recommendations and so on. You use them in all kinds of domains, fraud detection, product recommendation, image recognition, and the list goes on. In particular, things with voice are very popular, translation, machine-assisted translation, you name it, it's probably being done. So whenever we talk about advanced analytics, there's a kind of a structure that we typically go through, and the details change somewhat, but the key concept is that you take data in some various formats. You typically do some cleansing, pre-processing, and potentially feature engineering. And feature engineering is a fancy word for basically you just take the attributes that are available to you and perhaps use them to combine in some way, to combine or to manipulate or transform them into something that's more useful for you. So it might be that you've got a timestamp, and it might be more interesting for you to know the day of the week or the day of the month, or the season that occurred on, and so on. So you basically feature engineering and pre-processing and cleaning are all part of the things that we do. Once you get that into a pretty good format, it's into something that's you consider it to be reasonably clean and you can trust it. Then you start doing some modeling and using some analytics techniques. That's where you basically figure out various ways to create them. Generally that's a very iterative process where you do things with picking various types of models and adjusting the hyperparameters, which is nothing more than just the settings on each one of those models. It may be that you're adjusting the number of layers inside of a neural network. It may be that you're adjusting the number of nodes in a given layer, and so on. Maybe that you're picking various sort of activities along the way of maybe the activation function if you're doing neural networks or whatever it might be. And so after you do that tuning, part of that process is an evaluation. So that's where you typically take your holdout set, that you test the model to see how well it did at the end of the experience. Generally, the process of tuning, you're using a validation set, which is used to help you make the best of the model. Once you think it's good, then you actually check it with the test set and see how it is, and hopefully you succeed. There's various types of learning, and sometimes you'll hear people talk about 3, sometimes 4, sometimes 5. But generally speaking, supervised, we know that one. That's a very common one. That's where you're taking historical data that's been essentially labeled, or data that has been labeled in some fashion so that you know the values that you're trying to predict. And you're either doing things like classification, where you're putting something into a group or not in a group, right? So one of two groups. or maybe it's into multi-class. So maybe you're trying to determine what breed of a dog is, or if the type of a car, perhaps, maybe the manufacturer, based upon an image. Regressions, where you're trying to essentially predict a continuous variable, so a real number, to be able to figure out what it likely will be, ideally probably in the future or given some set of inputs. And then there's also this concept of kind of recommendation. This is where you're doing things like shopping cart analysis, to where people that bought these 3 things oftentimes buy this 4th thing, so maybe you want to buy that 4th thing. Or people that like this movie also like this other movie, right? So maybe Netflix is going to show you a particular recommendation based upon something that you've watched. There's also unsupervised, where you you do things like to try to detect anomalies. Maybe you're doing some clustering, some topic modeling, or segmentation. There's also graph analytics, where you're using the relationships either to predict things like fraud, classify, page rank, and so on. And there's also, not mentioned here, but this concept of reinforcement learning, where you don't necessarily have a labeled set like a supervised set, but you do have a way of determining what good looks like. So you have an evaluation function. And the approach is to have an algorithm that balances between utilization of that knowledge that it's already captured, so exploitation of the domain that it knows, with exploration at the same time. So it will randomly go out and try to find something that yields better results, but it'll also take advantage of the things that have been working well. So various types of learning. When we recommend based upon patterns, that's typically going to be the shopping cart analysis. You take a look at patterns of over time, and people that are buying milk and bread may also be buying eggs or cereal. So if a customer comes in and they have sugar and eggs, maybe they would like some butter as well, and maybe some milk. So it's making that recommendation based upon what others you've seen in other representations. Amazon has done that to an entirely different level. You do have to remember, though, anytime you're going with some of the recommendations, just because they're making a recommendation doesn't mean that it's necessarily truly something that should go with it. So if you're buying a part for your car, and an associated part is being offered to you as well, that may or may not mean that it actually is the right part to go with your part in your car. It may be that a bunch of people have made a mistake of buying the wrong part. So you do have to be cautious, but it is quite useful whenever you're looking at the association and the relationships between things, because it can definitely, it is. Associative rule mining was one of the first real applications of AI and analytics at scale, and it has taken off. There's definitely something to be said about it. So it's a good technique to know. So Spark MLlib, what is it? The short answer is a set of libraries that make it relatively easy to do ML-related activities, including gathering and cleaning data, maybe even doing some feature engineering and feature selection, some training, tuning of both large-scale supervised and unsupervised machine learning models. And it's also useful for using those models in production. You have transformers that basically are used to do, as the name kind of implies, they transform the data, so they convert data from one thing to another. You have estimators that are used whenever you're doing the training to actually kind of estimate a value. And then you have evaluators, which is you're checking to see how well it did. A standard transformer is something that takes in a data frame, that's what the DF is, and an input naming, does some transformation, and you get out of that an output name that you're also telling it. So it's basically changing or adding additional columns based upon what you're telling it to do. So with that, I'll shift over and do a little bit of a demo here. So what I've done, good or bad, is I took a look at Databricks has several notebooks out here on how to use MLlib on Databricks, right? So Apache Spark MLlib is a set of libraries. It is an open source thing. Databricks is a company which uses Spark open source technologies, and it's actually one of the biggest contributors to the Spark open source project, as the people that created Databricks created Spark. But they've kept it open, allowing people to continually extend and adjust as needed. There are numerous sort of resources, including an MLlib programming guide. But what I did was take a look at one of these example notebooks. And you have the ability here to copy the link to this notebook into basically your clipboard. And then if you go into a Databricks environment and inside of a workspace, you can import a notebook and give it that URL that allows you to basically bring it into your environment, which is what I've done here. I've got a cluster up and running that is a a machine learning cluster. So inside of Databricks, you have the ability to specify what type of a runtime you want to be using. So whenever you see that it is, it's runtime 9.1 LTS ML, that ML means that all the machine learning libraries that you're going to need are already installed, so you don't have to do a whole bunch of installations. You can do things like install libraries and so on. There's no real need if what you're doing is already present. And so that's why we're using an MLlib. So to step in through this notebook, the first thing I'm going to do is clear the state or clear the state and the results so that we can kind of experience it as we step through. So what this does is this notebook is around binary classification. So this is a fairly common thing. It's your two-class classification we just talked about. In this case, we're looking to figure out, based upon roughly 50,000 people, do they make less than 50 or more than 50,000 a year? The values that are in the data set include things like their age, their working class, so they private, self-employed, federal, state, whatever, work without pay. Kind of that would give you a hint on the predictive value there. If they're working without pay, they're probably less than 50K, right? And so on. So you have a series of data here. So the first thing we do is obviously go out and load it. It comes available from the Databricks data sets, easy to get to. This is something that they kind of do as a value add because people oftentimes want these types of data. So you can see it is there. Interesting sort of exploration if we take a look at what else they may have there. And what this is doing is %fs is a magic command that says run this file system command, and all we're doing is an ls of a directory that is off of the DBFS called Databricks datasets. And you can see there's COVID, there's airlines, there's Amazon, ASA, and so on, CS 101 or 100, data.gov, and so on. Lots of different stuff, including some flowers, the flights, some IoT, and the New York City taxi data set, and retail, and so on. This is just as a place to have data so that we can have it accessible to us. So we take a look at that that file, and we can see what the first bit of it looks like. So it looks like a number, the category, and so on. So then we basically create a schema and this is this notebook is in Python. And what this does is allows us then to read that data in a fairly strong way. So we're saying what the types of things are, what's a string, what's a double, and so on. We're reading the data set, and then we can actually take a look at what that data set looks like with these names, and so on. So this is going and actually loading it into memory at this moment. And you can see here the first column is age, then working class or work class, and so on. Their occupation, gender, race, and their income classification. So the first thing that we do is you've got to convert these categorical values into something that can be used. There's lots of different ways of doing this. You can do categorical indexing, or you can do the one-hot encoding. You can use either one, but the way that we do this inside of SparkML is through the use of a pipeline construct. It's not that dissimilar from a lot of frameworks that do some sort of pipeline approach. The reason that you do this in Spark is this is going to let the optimizers essentially come up with that DAG, right? So that directed acyclic graph that tells it what to do. So we're declaring the things we want to happen, not necessarily doing anything. So you can see here we're using a string indexer for the input of the categorical columns, and then we're doing a one-hot encoder on top of that to turn them from into if it's available, we're using that. So we're doing it either dependent upon the version of Spark, and this is a fairly generic notebook. We're well past version 3. What this is doing is, like it's saying, it's taking that string indexer, converting it into categories, and then into one-hot encoded variables, and this is essentially a binary vector that lets us be able to do classification. So if we could probably go through and do similar things on income. So that's basically going to be our target when it's all said and done, right? Then we do some more transformations along the way. You've got a series of columns, and we're doing a vector assembler. So we're turning these things into basically the stages, and we're starting to add this to the process. So that's a key concept here. When we do the stages plus equal, what we're doing is saying whenever you're running this pipeline, here's the series of that things need to go in. They're spread out across multiple cells, but that's exactly what it's doing. So then we're going to actually be able to run all of this stuff through to do the actual transformation. Then once you get past getting your data essentially to where you can use it, and we'll throw in a display prepped data df. And we can see what the results are like, and there should be some stuff out here at the end with some vectors, and these are sparse vectors that are letting us know this is the index, and this is what's where it's on. So with a sparse vector, the basic idea is you don't save the things that don't exist. So instead, you only have values where you need them based upon. So it's a way of preserving space and making things a lot tighter. So our next step is to go through and do the actual fit, and then take a look at essentially the area under the curve once it's all said and done. While this is running, it's actually going out across a small cluster, but I'll go ahead and pop that open so we can watch what it's doing. Also, an interesting data point is that Spark does allow, depending upon your environment, allow you to have GPU-based clusters and a runtime that'll take advantage of those GPUs. So we aren't really doing much to this. Looks like probably most of our time is being spent in the network, which is what it kind of looks like, and that wouldn't be too terribly surprising. This data is not really probably spread out nicely as well. And then we can take a look at the model. And showing that it's doing pretty decent. And taking a look at the labels and the features. Now we're going to do the taking our data, splitting it into the two sets of 70-30 for train and then test. And we'll see it's got a seed so that it's a reproducible output. So roughly 9,700 for the test set and 22,800 for the training. And then at this point we want to probably try out some different sort of classifiers. So logistic regression, a fairly popular one, and again it looks like a max iterations of 10. There's probably a reason that's the value. Then we can do some predictions and do evaluation of our binary classifier, and it looks like we're doing reasonable, almost 90%. That's generally pretty good, and it is using area under the rock as the metric for evaluation, and then we can explain the parameters so that it'll give us some sense as to how we got to where we were. And then setting up for cross-validation. Taking a little bit of time to run. And if you were doing this for real, you would spend some time optimizing your both your data and your cluster. So it looks like here we're in the process of doing the 5-fold cross-validation. Not surprising that that's taking a little bit of time. One of the things that is also wired up with these sort of things is MLflow. MLflow is a way of keeping track of machine learning experiments. You care about that because you can see up here where it says experiment and then 9+. There's a way here that you can basically go and see what was done when and what was the result. Becomes very handy whenever you're trying to figure out. I had one that did pretty well. Where did it go, right? You can also, from MLflow, save your model to a repository, and then be able to take that model with 1 or 2 lines of code and expose it as a serving model for use in a production sort of environment. So it makes life much simpler for you in general. So while this is running, taking a quick look here of what's going on the cluster. Does look like it's liking the network, right? So it seems to be where we're spending most of our time. The CPU doesn't look too terribly pegged, nor does the memory. And nothing over here is turning bright red. So it's probably all about transferring the data. So it is running through. Looks like we just finished up, and then doing the transform so we can get the predictions, and it's still around 90%. Then we can go and do the model intercept of the best model. Take a look at the weights and figure out which of these is probably the best. And so on. So then moving into decision trees. So again, we're basically just saying, take that training data, run it through calling a fit on a decision tree, and then see how many nodes there are and how deep it goes, and then we can actually see the model, which is quite handy. So you can see which features are being used to determine, and then you can actually make some predictions, evaluate it. Doesn't do nearly as well, only about 74% accurate on that. So decision trees aren't always in fact most of the time they're not really the best approach, but they're understandable, and because of that people tend to use them. So you can explain it, and explainability is an important element to consider whenever we're doing this sort of stuff. Doing some cross-validation. And again, going through, most of this is going to be spent on the fit. While that's running, I'll go ahead and show one other thing that's really pretty cool. One of the things that has been relatively recently released by Databricks is AutoML, and what you can do is basically tell it the type of problem you're trying to solve, and you do so by finding so we'll do Titanic. You tell it what is it you're trying to predict, survived, and basically you can then tell it how long do you want to run, or how many trials do you want to go through. Let's go ahead and kick it off. And what this does is basically tries all these sort of models for you, just like we're kind of walking through over here. We're going through the various types of models. We're doing logistic, we're doing decision trees, doing random forest. That's exactly what AutoML does for you, but it does it at a larger scale. So it literally goes through, we tell it what it is that we are trying to classify, and it basically figures the rest of it out for you. And then it goes through and starts trying all of the various models it knows to figure out which one gives you the best result, and the best being defined whenever we created this experiment. We told it we left it to the default, but it was basically what calculation we wanted to use, and I believe it defaults to F1. So here we've ran through, and even after all of the cross validations, it's still about 75.5%. So moving on to the random forest, similar sort of thing. You basically call it, you're making some predictions, taking a look at the schema, and then evaluate it. And it does better than the decision tree, but still not as good as the logistic regression. And again, running through cross-validation. And then we can go through and basically say, well, give me back the best model, do some predictions. And while it's running all that, we'll pop back over. So we're basically going through and letting it queue up some stuff and run. We are running on the same cluster, so we could negatively impact the performance. So model training failed for some reason. Let's see if I can figure out why it didn't work. probably my data. Doesn't tell me why. So this is the run. This is a data issue. Inside of that data, there's actually, and I should have used a different example. But so inside of this raw Titanic, there is a column name with a period in it, I believe. Home underscore or home dot destination. That's why it died. It didn't like, it wasn't expecting that. So maybe I'll try a different one. Maybe Iris. We're going to predict class. Down and through here on these advanced is where we're saying what the valuation metric is. In this case, we're using F1 score. You could go to accuracy. F1 kind of balances between those two. We'll go ahead and kick this off and let it run. During that time, we basically, it finished up this other, so we can basically see the predictions and the counts based upon how well we got as far as doing our predictions. So this is a pretty good, you're not far away from at this point being able to actually use this if you were so inclined in a deployed sort of fashion. So shifting back over to our Iris, does look like it's actually going to go this time. One of the nice things they do for you is you can see this, it now has a view data exploration notebook. What they do for you, it's a little odd, but it's quite useful, is essentially go through and run a notebook for you that takes that data and does some profiling on it using Pandas profiling to do a profile report. And what that does is then let you go through and take a look at the overview. You can see the various variables and their histograms. So you can see what kind of distributions. You can compare interactions between variables. So you can see kind of a visualization of the data. So kind of useful. Correlations between various variables. Obviously high correlation whenever it's the two on the two variables are the same. Lets you know what missing variables there are, if any, or missing values. And then gives you the head and the tail of the value, and then plus the most frequently occurring. So it does a bit of profiling for you to kind of get a quick understanding of the data. Then it goes through and is actually running reports or results, and we get back and we can actually sort by accuracy, and both training accuracy as well as the F1 score, and so you can get a sense of which ones are going to be doing the best. This is the best one so far, and you can actually open it up, and this is the part that's really cool that Databricks does that I don't think anybody else is doing. You can actually see the notebook that they created to determine their predictions, right? So you can go through and then to kind of take a look and see exactly how they did their process. So interestingly enough, you go through and actually pull in sklearn, and they're not necessarily using MLlib in this, right? So not using MLlib, but are using sklearn, and goes through, and it is a similar process. You have this pipelined architecture with a series of events that are being done. Similar also, you're going through and doing a test train split. You're splitting off of the data, and then in this case stratifying it off of split Y, and then do some training, and you can see the visualization of the actual pipeline that it's going through those various steps. Then actually does the run, stores those values out in ML Flow so that we can actually see what's going on. Do some feature importance, so determine which features are the most important if that's enabled. So if you want to see it, you can turn this on and run the notebook again. Again, this is running on the same cluster, so it's having to kind of fight for resources. This is also a standard cluster, not necessarily optimized for concurrent workloads. It's just kind of intended for a single job at a time. So here you can see the kind of the diagram showing feature importance, and kind of looking like pedal width is kind of important. Also, things are going into the model registry, and this lets you, this line right here of load, if you want to load them from the model registry, you basically have the model name and the versions, and you basically say mlflow.python.load model and the name that you're interested in, and you basically then can do a prediction based upon some values. So that's what you would do to actually serve the model, which is quite convenient and powerful. So with that, I'll go ahead and wrap this up. If you have any questions, let me know. Oh, well, actually, no. We need to talk about the deliverables, right? So deliverable 6, you're going to apply SparkML within the context of Spark Scala or Apache Spark, and so you're basically to create a video that explains what machine learning is and what it can do, a description of the different types of machine learning models, their purpose, and how they compare to one another, and provide examples of each. You're to try to keep it to where you're not necessarily using jargon. Try to explain it in such a way that people can understand what you're describing. Make sure that it is professional in content and tone. Record it using whatever you want to use, and also use Word to write an article that will be placed on the company's webpage with the intent of basically providing additional information about the video, and make sure that it includes the two algorithms of content-based filtering and collaborative filtering, and also a definition of Apache Spark, what it is, why you would use it, and a definition of Scala, what is it, why do you use it. Here's some resources that are relevant, and your rubric, as always, shoot for that the green column, a thorough and detailed article free of errors that provides additional elements complementing the video. The 4 factors that can be used in a combination, in a recommendation engine, an explanation, and examples are provided for each factor. I got a duplicate slide. Your article is free of errors, and you have a video. On deliverable 7, this is kind of your competency is to show pretty much that you got everything in this course, right? So you're basically going to pull together, so as you've done, you created a cluster, even in the Windows Subsystem for Linux, perfectly fine. It's a single node cluster. Cluster will be utilized to do basically just having created it, and talk about how you created it, and then the rest of that's not relevant. So your more detailed instructions basically go through and talk about the process you went through to create your cluster. Then talk about what is HDFS, what's a name node, how do you read and write, and so on. A simple Java program that writes files and reads files from HDFS, and a screenshot of your work. Then the third point, using similar concept with Hive, so basically doing HiveQL, write some 10 queries that basically filters, transforms, visualizes data, pretty much reusing what you've done in the previous assignments. Then talk about Spark by talking about a Jupyter notebook. Databricks notebook is perfectly fine. Write Spark SQL statements that transform, filter, and visualize your data. So that's the Databricks Community Edition, be a perfect fit here. That's what I would recommend. Scala's up to 100 times faster, but at least 10 times faster whenever it's dealing with the disk drive. And that the statement in number 5 isn't necessarily true if you're using Python on Spark. But anyway, so basically create a Jupyter notebook or a Databricks notebook, and then do some examples that contain some Scala code. Tons of Databricks notebooks out there. Personally, I don't care if it's Spark or Scala or Python. It becomes where languages are relevant. As mentioned above, define and explain what a machine learning data pipeline is and how you do it with Spark. Resources, and then the rubrics. It's just a restatement of the one that's in the course room. As always, if you have questions about this material, let me know. I'll talk about this stuff again more as we circle through. So if you have any questions about anything I've went over, let me know. That's what I'm here for. And with that, I'll speak with you again next week.